Okay, so last time we solved exponential equations, and remember the thing that we learned at the end was that logs undo exponents, right? Okay, that was the new rule that we learned, how to solve if you don't have common bases on both sides, then you can use logs to undo your exponents. That's what we did on 7 and 8. And then on number 9 and 10, natural log undoes the natural base. Okay, those went together. So that's just a reminder. Today's going to be kind of similar to that, but I think even easier. Right. First problem, we're going to start with the natural log. Ln 4x minus 7 equals ln natural log x plus 5. Okay, so if you remember last class, when they had common bases, what did we do if they had common bases on both sides? Just solve the equation, right? And this one has common logs on both sides. So what do you think we're going to do? Just solve, right? If they both are natural logs, you can ignore it since it's on both sides and just bring down the 4x minus 7 equals x plus 5. I always like to put a 1 in front of there so I don't forget about the number. We can ignore the natural logs while we're solving. Still part of the problem, but we don't need them. Okay, since they do it on both sides, they kind of cancel each other out.
Minus 1x.
Okay. Minus 1x is what I would do. Good. Then plus 7. And then divide by 3. What's 12 divided by 3? X equals 4. Good. Okay. All right. It's just that simple. It doesn't always have to be a whole number, right? But most of the time I make them pretty easy whole numbers so that you feel confident about it. Okay. Now, remember all of these. If I plug in my x is 4 where the x is on the left-hand side, then I plug it on the right-hand side, I get the same thing. They should be equal. If you did it right, you can check them that way because it's an equation. They should be equal. Okay, so there's number 1. We'll do another one on number 2. I want you to do this one on your own for me once we get started. Right, this one is log. This was natural log. This is just going to be a common log. 5x plus 2 equals log x plus 1. Okay, do they have common logs on both sides?
Yes.
Yeah, so we're going to do the same thing, right? We'll just ignore the logs right now and just do 5x plus 2 equals 1x plus 1. I'm going to let you solve it, and I'm going to come around and check your answers, okay? This one, you might not get a whole number, okay? It's okay if you don't get a whole number. You can use a fraction or a decimal, whichever one you feel more comfortable with.
I got a decimal.
That's okay. But
I mean, negative.
they're actually not. No, they're pretty light. It's just good because I have to check that always. If they're heavy, then I can't figure it out. Because, you know what? They hurt. So far, so good?
Oh, yeah. No.
Too bad, not everybody gets it.
We're on a roll, you guys. Everyone has signed it right.
Oh, and she got the green color. You know who wears green? Santos. It's one man.
It's the same thing.
You
It's
do.
like 1 + 2.
It's one minus.
Damn, I did all
It's the same exact one minus two, not one minus negative.
The champions of mention. So what you have? You see that crown?
One minus two.
Yeah,
Not one minus.
yeah.
Okay.
Right here.
Okay, so we got -1/4, yeah? Or -0.25. Okay? Right? I don't care if you use a fraction or a decimal. This decimal doesn't go on forever, so I don't care. Okay? If it goes on forever, you've got to use a fraction. Right? We don't like the repeating decimals. Okay, so if they have common logs, it's very straightforward, very easy. Okay, of course, we're not always going to do it that way. Here we go, log base 2, 5x minus 17 equals 3. Right, is this one like the other two?
I can see the thing, but it's supposed to be some other stuff behind 3, but it ain't. So they not the same.
Right, exactly, right? It doesn't have a log on both sides. So we're going to do kind of like we did last time where we learned a new rule. Okay, logs undo exponents, and also exponents undo logs, exactly, okay? There they go back and forth. So exponents undo logs, so we're going to do something, a new word called exponential.